Okay, paper 2, question 11, part C. If we insert a calculator page, we're going to be asked to do a probability calculation. So we'll do menu, probability, distribution, and we're going to do a normal cumulative distribution function. Now the lower bound we're interested in here, well, it's between 64 and 80. So what we could do to start off with, I could just type in 64 and 80. The mean of the distribution is 75. The standard deviation here is 7. When we execute that, we get the decimal 0.7. Now that's the probability of one individual student being in this range, and we've got a huge sample of 400 of them. So if I just simply did 400 multiplied by that previous answer, I get 281.7. So around about 282. Now you may disagree with that calculation. You may consider that for the nearest kilogram lying between 64 and 80, what we need to do is actually think of the lower bound not as 64 but 63.5, and think of the upper bound as 80.5, but otherwise everything else in the calculation remains the same, and we get another dozen or so people that are possibly in this range. So be very clear when you're writing a solution whether you are making any assumptions about the rounding nature of the numbers 64 and 80. And when we go into part 2, number of students whose weight to the nearest kilogram is more than 90, well, what we need to do is do a similar sort of process. We're going to go more than 90. Let's just go back up to this first one that's got smaller numbers. I'm going to go with 89.5 in this particular case, but again you could use 90. We want to go all the way up to infinity. Infinity is quite a large number, so what we can do is do 9 EE99. That's a pretty big number. That's close enough here. Pressing enter gives us around about 7 or 8, depending on your rounding. And the question is done.